This is like GnarCairo, and here's a bit about Gnark. So it's like a ZK library written in Go, and it has a huge library of highly efficient, ready to plug in implementations of circuits that you can use to build your applications. And it supports a lot of different curves, so you might have different cryptography algorithms that you might want to implement. So Gnark is like a place to be if you want to do that. I'm not going to talk a lot about Cairo and Starknet because Charlotte has covered it quite in depth. So it's just like a Rust-like language. It's for verifiable computation, which is powered with Starks. And newly introduced feature in Cairo is this highly efficient field operations emulated for any curves that you might want to emulate it for. So here's a bit of an intro on Starks versus Snarks, and I'm not going to talk too much about this one either. So moving on to GnarCairo. So GnarCairo takes your Gnark emulated circuits and converts them into Cairo circuits. And it has batteries included, which I'm going to talk about later what that means. So I'll go to fields and I'll just delete all these and move to trash, contracts as well. Move to trash, I'll clear out the library and save. And now I'm going to go ahead and go into this thing called Cairo test. There's a reason why we are doing this in this way and not with a standard, just like a simple, like a terminal command execution, which we will get into it shortly. So there's a bunch of stuff over here. I'm going to go ahead and kind of try to clear it up. And I'll go and so this is like how by standard like Gnark works. You define your circuit and you define your constraints for your circuit, and that goes into the definition for your circuit, like it's over here. With Cairo circuits, what you want to do is you want to put everything that includes the constraints that you put inside Cairo inside this function that runs inside this Cairo circuit package. So I'm gonna start with something rather simple, and I'm just gonna include add for now, and I'll just go ahead and comment these out as well. I'll duplicate this, comment this out, and so we can see what it looks like for a very basic example. And we will also talk about what I meant by having batteries included. So now if I go ahead and try to open this here in my terminal, we can see that there's nothing in the source right now. There's just a lib. And now I'm going to try to do some tests, run some tests. And I'm going to try to run fields and, sorry? Zoom in a bit more. So I'll move this away, and I'm just running the test here, and I'll just pass in the name of the test that I just wrote. I didn't really write anything, I just trimmed stuff out. So the test for this is this one. No, this is just this is what runs the test. And now I'll just go ahead and do the stuff that I just did, which was like removing this stuff with the stuff that I just edited. And let's walk through what's going on here. So you start by defining your circuit, and circuit takes in and out. So we take two field elements and we output one field element for now. And our circuit includes a test to make sure that the addition that we received from the circuit matches what was in the constraints. Finally, this is where we run our tests. I'm again gonna comment out the rest of the stuff because we don't need it just yet. and it might throw an error because it's like quickly put together. So I'm just gonna try to run it and see if it's gonna let me run this. I'll just paste this here, and I cannot run this. It says there's an error, expected declaration found package, and oops, so we're gonna need to clear that up. And we can also remove these because we don't really need these right now. I'll do this because I'm gonna need them later when I show a bigger circuit. And kaboom, that should be good, and that can be commented out. Now it should be good, and okay, that test ran. And let's see now what we got. So you notice immediately that there's this new FP1 file that is created, and this FP1 matches just a second, it matches this name of the circuit that you provide. And let's see what's inside that file. So this is a lot of circuit stuff in Cairo, and what this basically did it is created this circuit function which basically takes in your inputs, which are 2 elements, and it provides 1 output, and that is basically all it does. And then what I meant by batteries included is that you just don't want to write a circuit which is rather cryptic. You want to be sure that it is going to work the way it should. So, and this is also why we generate it via the tests and not via the CLI, because when you do it like that, you have the values available for your constraints, which you don't have when you're just creating the circuit, when you're just building the circuit. And because of that, now we can define a default circuit input and actually test it inside Cairo here. And this line over here, which basically does the assert. So it's checking that the add matches a specific provided input for your tests. Same thing is happening here. It's just testing that what the circuit gives us for this input is what we expect. So that is the batteries included part. This one seems rather simple, and you might feel like, okay, why can't I just write it myself? The reason is that you want to have circuits which are far more complex, and I'm gonna undo a couple bunch of times, and undo a bit more maybe. And now I don't just have like super basic addition, I have like addition, subtraction, multiplication, division, and inverse for the single field elements, but also for the field extensions E2, E6, E12. And this is just a bit of the fun that I was trying to test. So I just did like twice the operations in E12 just to make a big circuit. So now we can go ahead and run our same thing again, but this time around we're just gonna try to remove this so that it can run everything that is in here, and hopefully that should work because all my tests have that prefix. And let me try that. All right, actually it did not work, I think, so maybe I'll just try to okay, maybe it worked. It's just I didn't use the verbose, so I didn't have a more info about the tests that were run. Oh yeah, so it did run everything, and now we see that we have all this stuff generated here, all these files, and now all these files actually have everything that we need. So this FP1 circuit still looks rather simple. It's just, you know, 2 inputs and a bunch of operations to test how everything's working. And again, the tests check if everything is working as it should. And now we can get into more complicated ones like FP12X2. So this one, things get a bit more tricky. Now you get like, you need to use like 24 inputs, and for that, actually I will not talk about complicated Cairo parts because that will just make it more long. I'll just show what it's doing. And now here you will notice that it didn't just have these inputs, but it also had certain constants which need to be provided at runtime. Gnark allows you to do that, but when you write a purist circuit, it doesn't have a concept of constants, so you need to provide everything when you run the circuit. But as a developer, you don't want to provide it in input, so we just bake it into the circuit generation. And these are the constraints which I'm gonna just move past because yeah, now you can see the circuit is getting complicated and the constraints are not so easy to wrap your head around, unlike before. So now we can see like these are the constants which are, you know, like the 9, 2 and 0, which are needed by our circuit, which are also provisioned within the code generated. And finally, we just run the circuit and provide the input provide the output containing exact number of outputs expected in the circuit. And again, this comes with tests as well, and it has everything it expects, and it checks for it. And we also include a little bench function, which does not do any check. It's just there to see how much gas your circuit is consuming. And yeah, that's pretty much it. Oh yeah, one thing that I want to show as well. Yeah, this is a little thing, not really worth showing, but it also added all the modules into your lib. And now what we can do is we can actually go into we can actually run the Cairo tests to just make sure everything is good. And now I do Cairo test. Cairo test, and boom. And we can see all our circuits are running, and we have the runs which are actually checking that the output matches what you expect, and also the bench which just shows you how much gas your circuit is using. And yes, that's the end of the demo. So, any questions? Yeah. Sorry?
Why is this circuit that you're discussing? What does it do to
What the circuit has to do with Gnarks? Nothing in particular. The good thing about using Gnark is that you don't have to write. So in my Cairo test, you can see that I'm just doing like, just doing add, sub, and mul, and div, and this is on like E12 elements. So it's usually not as simple as that, and it has a lot of operations that you need to do. When you use Gnark, you have the most efficient ways to do that written in Gnark, and that allows you to build your whole circuit much easily.
So you're just, you're kind of tweaking the existing language, sort of like how you write assembly.
Sorry?
This feels like to me you're almost writing like custom assembly code and switching the back end. Or at least how.
Sort of. I'm not sure it's exact assembly, but I would say that the Cairo circuits are rather low level and are a pain to write. So this kind of helps with that. But also like you could just as easily use something like, SHA-256 if you want to use it in your circuit. And Gnark has a lot of those things along with the different curves. So yeah, it's for that. Cool. Any other questions? Yeah.
So the code generation is running in Cairo, and the generated code is in Cairo as well, or the generated code is in Europe?
The generated code is in Cairo, and the tests happen in Cairo as well.
Okay, and that emulate was all the code generation directives, and they were in Cairo as well?
The emulate part, which was like in the tests. You mean in the tests?
How do you generate code? I thought it was.
So, oh yeah, yeah, yeah. So emulate is this package in
Uh-huh.
Gnark which is used for emulating certain curve fields in different curves. So you have a different finite field and you're trying to emulate different finite fields. So I basically expanded upon that functionality to do it for Cairo, because technically you're just emulating another field in Cairo.
All right.
So a lot of code which Gnark people have written can be reused.
Thank you.
Sure. Guys, any other questions?
What's the performance of the output like? Because normally when you generate code, you have
Yeah.
like significant performance.
Okay, no, no, this one is gonna be the top-notch performance because I've personally edited a bunch of stuff to so like you match the number of constraints that are in the algorithm exactly into Cairo.
Okay.
So you have no overhead. You have a little overhead which might have to do with like creating the array and no, no.
Just setting up everything.
Yeah, exactly. So like if you want to do some SERDI and stuff when you actually deploy it to a contract. So I also did this FP12 X2 this one. I tested it. I deployed it on test Sepolia to see how it works. It was quite nice.
Thank you.
Cool. Cheers. Is that all, guys? Oh yeah.
This is more, because I don't really know, I'm not too familiar with how the Gnark should go. So
Yeah.
why is it in Go?
I think they just choose Go. But right now, like Gnark is the, as per my understanding, how much I know, it's by far the farthest, by far the fastest when it comes to certain implementations. And I wanted, when I was gonna, when I wanted to import a bunch of stuff pre-built, I wanted the stuff which was the fastest, obviously. So that's why I used
Do you
Gnark.
have like a low level documentation that you can read?
Yeah, yeah.
That can explain
You can go
why they
to.
go, why, exactly what it is that you're doing.
It's this link over here, and it's just I think design decision they made, and
I'm seeing a lot about, they're iterating on different curves, but not
Yeah.
seeing a lot about,
the reasoning for choosing Go.
or some, it's some low level stuff, like, I think they just scratch too much. Or it's hidden somewhere in the document.
Oh, oh yeah, could be. To be honest, I haven't read a lot of docs. I've just been through the code base. I was talking to someone quite a while back, and they were implementing something in this new language called Elixir. And I was like, why are you implementing in Elixir? They said that they just wanted to. And I was like, yeah, sure, okay. So that's what I thought and assumed, and I did not decide to dig any further.
That's fair. Yeah, that's troubling. I mean, to me, that's troubling.
What is?
That, I mean, I'm sure there's a good reason for why they are doing it.
In Go?
Yeah, or Elixir or Go, whatever. But if they're not describing some of the lower level reasons, then it's like hard to conceptualize or be doing.
Yeah, personally, I picked Gnark because the guy who is doing a lot of stuff on this, Yusuf El Husni, he's very remarkable, and he's done a bunch of white papers exploring highly efficient, like I would say downright the most efficient algorithms for doing these operations, and they are in Gnark, so I just use Gnark because I care about the algorithm itself.
I think it's like when you have true complete language, you don't really care what you write something in. It's like at the
Yeah.
end of the day, it's the same or almost the same binary code.
Yeah,
The
yeah.
thing is, I think it's just Gnark is the most optimized and the largest library, like the most used.
Exactly.
It just makes a lot of sense to use Gnark.
Exactly, exactly. Yeah. Cool. So guys, is that all? Any other questions? Nope. Oh, yeah. This was, well, you can call it research and also like just having fun, but it was also supposed to Um, I'm trying to write some front-end proving library and um, not naming anything specific. The way things happen right now is not ideal for front-end proving. So I also need to rewrite some of the some of the verification stuff so that it's more suitable for front-end proving. And for that, I would prefer. I've already written like Growth 16 verifier from scratch 2 times this year. I don't want to do it the third time, so I'll just use Gnark to do it this time. Yeah. Cheers. All right, guys. So that's a wrap. Thank you. And I'll stop the stream.